Can we, and should we, trust a correct answer we do not fully understand? This isn't just a thought experiment anymore. Today, real quantum machines are outperforming our best classical supercomputers on specific tasks. They are delivering results that work. Yet the inner workings of these machines are so foreign, so counterintuitive, that even the scientists who build them can be left scratching their heads. We are standing at a crossroads. We must decide how to use a tool whose intelligence may operate beyond our full comprehension. The feeling is excitement. The feeling is unease. On one hand, we have a powerful new ally. Think of new medicines, better financial models, more efficient energy systems. So, what makes a quantum computer so different from the laptop or phone you use every day? It all comes down to the basic building blocks of information. Your current devices use bits. A bit is like a light switch, off or on. Classical machines check one possibility at a time, just very, very quickly. Quantum computers use qubits. A qubit is more like a spinning dimmer switch. Thanks to superposition, a qubit can be 0, 1, and everything in between at once. Like a coin in flight, both heads and tails until it lands. This lets a quantum computer explore many possibilities simultaneously. Qubits can also be entangled. Whatever happens to one affects the other instantly, no matter the distance. Einstein called it spooky action at a distance. Entanglement creates vast computational spaces classical machines cannot match. By linking qubits, we tackle problems of overwhelming complexity. Quantum does not just go faster. It computes differently. Building and controlling these machines is incredibly difficult. Qubits are extremely fragile. Tiny vibrations or temperature changes can cause errors. For decades, scientists have developed shielding and quantum error correction. Today's breakthroughs come from this painstaking control. Now let's look at what this new power can actually do. The years 2024 and 2025 have been monumental for quantum computing. We have moved from whiteboards to verifiable results. Google's Willow quantum chip achieved a stunning demonstration. It performed a computation in under 5 minutes. Google stated the fastest supercomputers would need 10 septillion years for the same task. That number dwarfs the age of the universe. Google's quantum echoes also computed the OTOC 13,000 times faster than top classical algorithms. Quantinuum unveiled generative quantum AI, training AI on quantum-generated data from its H2 computer. Its leadership said the hypothetical is becoming real, with transformative commercial potential. HSBC used IBM's Heron to boost bond trading predictions. They achieved a 34% improvement versus classical alone. One of the first publicly verified commercial quantum advantages in finance. D-Wave directly simulated a quantum magnetic material, a task too complex for classical computers. Simulating quantum systems with quantum computers opens doors in molecular interactions, medicine, and even blockchain efficiency. We have powerful machines giving amazing results. But why do the answers feel mysterious? Quantum algorithms run through superposition and entanglement, a vast landscape of possibilities. We only observe one classical answer at measurement. It's like seeing the final photograph without ever seeing the camera or the photographer. Quantum processes create subtle, high-dimensional patterns. Some patterns simply do not exist classically. When asked to explain in classical terms, the AI can't. Like describing red to someone who has only seen black and white. Some answers are easy to check, like multiplying prime factors back. But for simulation or global optimization, fast verification may be impossible. If classical verification takes millennia, we face a gap, result without quick proof. Hardware noise and error correction add complexity. Sometimes a correct-looking answer emerges from computation plus corrected noise. Disentangling the true path is hard, making the process feel like a black box. The trust paradox is a classic double-edged sword. On one edge, the rewards are dazzling. Quantum AI could accelerate drug discovery, life-saving medications for Alzheimer's and cancer, even first-round virtual trials, safer, cheaper. Optimize shipping, reduce traffic, design efficient power grids, new materials and carbon-pulling catalysts. But the other edge is risk, hidden flaws. A strategy that wins 99% of the time could fail catastrophically in rare events. A new material might hide a bizarre vibration weakness. Without explainability, we are flying blind to corner cases. Opaque systems risk bias in parole, loans, and medical decisions. Accountability questions erode public trust. Transparency is essential to earn that trust. If you're learning something new, smash like and subscribe right now. It tells the algorithm to share this with more curious minds. Turn on the bell so you never miss verified breakthroughs, not hype. Next up, a practical guide to use quantum winds safely and your role in shaping this future. How do we navigate this paradox? Build bridges of trust. Step 1. Rigorous testing and validation, even without full explanations. We can still check whether an answer is good. Compare quantum outputs against multiple classical baselines. Cross-check across algorithms and machines. Keep simpler models as sanity checks. If classical models confirm stability, confidence grows, even if we don't see all the reasons. Let quantum provide the leap. Classical provide the safety net. Champion open science. Share data, methods, results when possible. Create public benchmarks for fair comparisons. Invest in quantum explainers. Flashlights in the black box. Partial pathways and salient inputs can still build intuition. This isn't just for PhDs and big corporations. It will affect everyone, and everyone has a role. Start with curiosity and staying informed. Seek balance. Be skeptical of hype and panic. Ask how products are tested and validated. Connect quantum potential to problems you know. Insist on transparency, oversight, and clear responsibility. Your voice helps build the guardrails we need now.